Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our video lecture series, we are going to discuss about the topic circulators. This topic comes under the Unit 1 Microwave Passive Devices of Optical and Microwave Engineering course. So, let's get into the topic. So, what is actually a circulator? Circulator are micro-optic devices and can be used with any number of ports. However, commonly the third port and fourth port circulators are used. It has relatively low loss, that is 0.5 dB to 1.5 dB port to port. So this is the structure of circulator. So it is why it is called as a circulator means the shape of this device which is in a circular manner. So here we have the ports are there, port 1, 2, 3, 4, and the movement of the power which is indicated by the arrow line. So this is all about a circulator. So the basic function of a circulator is shown in the figure. The light entering at any particular port is, for example, you take as a port 1, travel around the circulator and exist at the next port. Say there is a port number 2. So light at port 2 leaves at port 3 and so on. So the device is symmetric in operation around the circle. Circulator or micro-optic devices can be made with any number of ports. However, third and fourth port circulators are very common. So, and this having very low loss, and the port loss is around 0.5 to 1.5 dB. And couplers and splitters are used to combine optical signals and or split the optical signals. So the vast majority of single mode optical couplers employ the principle of resonating couples. Two SM fiber cores are placed parallel and close to one another. Optical power transfers from one core to another, and back by electromagnetic wave in the induction. Power coupling depends on length of the coupling section. So let's take up the classroom activity. So the image which is shown in this slide, which is actually a rebus puzzle. So we know already we are practicing this rebus puzzle in so many classes, and we have a team. You discuss with your team members and find out the answer for this rebus puzzle. So let's continue the session. Here, according in the concept of splitter and couplers, so there are some losses we have to see. So first thing is return loss. So the amount of power reflected and lost, that is called a return loss. Then what is insertion loss? The amount of signal lost in the total transit through a device is called insertion loss. Then excess loss, additional loss of the device above theoretical loss. Okay, so a type of couplers, there is Y coupler, star couplers, fused fiber, and in this according below the star couplers we have fused fiber mixing plate, planar, there is a free space 3 dB coupler. Filters. So filters are used to select the signal in transpath and receiver from many signals. The gratings or filters, switches, modulators, AWGs, multiplexer, etc. are considered as a type of filters. So the types are Fabry, Perot, tunable filter, in-fiber Bragg grating filter. So what is the use of this filter? So filters are used in front of LED to narrow the line width before transmission. Filters will be very useful in WDM networks. For why? Because the filter placed in front of incoherent receiver can be used to select a particular signal from many arriving signals. And a WDM network are proposed which use filters to control which path through a network signal will take. Fiber Bragg gratings are the most important optical filter in the communication world. So you can see the input in this diagram. The input is there and output section is there. So input is lambda 1, lambda 2, and lambda 3. And in the circulator, when the light moving, and we will be getting at the output side because of the splitter and the couplers. So output section we have lambda 2 and lambda 3, where lambda 1 which is mentioned in the down arrow mark. So let's take the assessment. The first question, what is circulator? Second question, what is fiber Bragg ratings? Next, list of couplers. What is filters? Next one, what is excess loss? Thank you.